Hey, beer. What's going on? I'm gonna edit some things. Part 6 today. Let's just go into the scene. Why not? Hi, everybody. Still wearing one of my favorite shirts in the world, the Pizza Planet shirt I got from Disneyland. I love the shirt. Such a nice shirt. My favorite shirts. I did wash it. I'm not insane. But yeah. Hopefully everyone's doing well. Hopefully everyone had a good day off yesterday. Oh, something fell off. Oh, okay, I don't fell off. My table is crowded and full of like weird stuff that I really shouldn't have. I should put some of these things away. Okay. Alrighty. So, hopefully everyone's having a good day. So, I'm going to actually do something a little bit different. I said I was going to do CCS or CSS last time, but I kind of wanted to jump into SQL. I'm not too sure. I mean, I know why I want to do it. I kind of know why I wanted to do it, just because I thought it was a lot of people say that they want SQL. People want to know how to do SQL. In terms of like jobs and stuff like that, which is kind of funny. So, and I was looking at some job postings just the other day. So, I'm like, might as well just do SQL. I think that might be a really good idea. So, I'm just gonna turn the audio up a little bit, not too high. There we go. So, essentially, we're learning almost like a whole new language a little bit here, which is gonna be kind of fun, but kind of scary. This is stuff I've never done before in my entire life. So we're going to see what happens with SQL. So SQL means Structured Query Language. It's a programming language designed to manage data stored in relational databases. SQL operates through simple declarative statements. This keeps data accurate and secure and helps maintain the integrity of databases regardless of size. So lots of stuff is actually SQL related in terms of like let's just say like banking information is kind of like SQL sometimes. Some pretty complex databases are actually done with pretty simple SQL items here. So understanding SQL is definitely going to be a big plus if we want to do anything in the future, especially if I want to start making like interesting little like databases. You know, keep track of all my whatever's. But yeah, 100% very interesting. I do want to do more of that. Give me 1 second. I'm gonna put some envelopes away. Okay, sorry about that, guys. So yeah, SQL language is widely used today across web frameworks and database applications. Knowing SQL gives you the freedom to explore your data and the power to make better decisions. By learning SQL, you will also learn concepts that apply to nearly every data storage system. So, you know, big data is all about that. You know, knowing your SQLs. The statements covered in this course use SQLite Relational Database Management System, RDBMS. You can also access glossary of all SQL commands taught in this course. Ooh, so if you click that, I'm pretty sure you get a lot of cool stuff in there, but I'm like, whatevs right now. So essentially this course is going to be fairly short in terms of like how many things you're going to be learning. Manipulation, table, and then SQLite, and that's really about, or actually, you know what, manipulation, queries, aggregate functions, and then multiple tables. So let's just jump into it, see how far we get, and yeah, we'll take it from there. So let's begin by making an SQL command. In the code editor, type select asterisk from celebs. You'll run all your SQL commands in this course by pressing the run button at the bottom of the code editor. Okay, so our first one's going to be select, and then star or asterisk from, I can guess from, and then celebs. So I'm doing some kind of celebrity. We're making some kind of celebrity database. Whoa, look at all these celebrities. We know that Justin Bieber is not 22. Is he 22 right now? Beyonce Knowles is 33. Jeremy Lin is 26. Taylor Swift is 26. This is a little old. Pretty sure. Give me a second here. I'm curious now. How old is well, no. How old is Taylor? She's 32 years old. So this thing is about 6 years old. This thing's about 6 years old. So yeah, no. Anyways, so in one line of code, you return information from a relational database. So we had a database that we just popped out somehow from the test.sqlite thing here. So pressing run gives you that kind of deal, which is kind of cool. So let's take a look at what's going on here. So we'll take a look at what this code means soon, but for now let's focus on the relational databases and how they are organized. A relational database is a database that organizes information into one or more tables. Here, the relational database contains one table. So this is one table right here. A table is a collection of data organized into rows and columns. Tables are sometimes referred to as relations. Here, the table is celebs. So we have celebrities as a table right here. Oh, I forgot to do something. Give me 1 second here. Boot myself in the... Oh, did I do something? I must have done something stupid. 1 sec, hold on. I must have done something real dumb. There we go. There we go. I think we're a little bit better now. Yeah, we can hear, right? Yeah. A table is a collection. Okay. A column is a set of data values of a particular type. Here, ID, name, and age are the columns. So, obviously, they're kind of breaking it down for very simple stuff. ID equals to 1. So, whatever new IDs we come up with, or whatever new entry we come up with an age, there'll be a new ID set up for that right there. Wow. Okay. Anyways, all data stored in the relational database is a certain data type. Some of the most common data types are integer, a positive or negative of a whole number, text, a text string, date was formatted, and real, a decimal value. So real number. It could be real number, point, whatever. Now that we have an understanding of relational database, let's look at Sql syntax. Okay, so we're going to look at what the stuff means. Okay. The code below is a SQL statement. The statement is a text that the database recognizes as a valid command. Statements always end with a semicolon. So what they did was create table name, column 1, data type, blah, 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 and they close it off with a semicolon right there. So far, so good. Let's break down the components of a statement. Create table is a clause. So what are we trying to do? We're trying to create a table. So it's telling this the machine that it needs to create a new table. By convention, clauses are written in capital letters. Clauses can also be referred to as commands. So basically, yes, table commands, whatever you want to put it. Yeah, table name refers to the name of the table that the command is applied to. So essentially, the name is the associated name for table name is for create table. So there you go. Column 1 data type, column 2 data type. Column 3 data type is a parameter. A parameter is a list of columns, data types, or values that are passed to a clause as an argument. Here, the parameter is a list of column names and the associated data type. So essentially, there's 3 columns under the table name of whatever this is, which is in this case table name, and then we created a table. So if we work backwards from what we just talked about, this is what's happening right now, which is kind of cool. The structure of the SQL statements vary. The number of lines used does not matter. A statement can be written all on one line or split up across multiple lines if it makes it easier to read. In this course, you will become familiar with the structure of common statements. So basically the most easy statements, from whatever. Let's take a closer look at the statement we wrote before. In the code editor, type select. So remember, they have that convention. I mean, it doesn't really have to follow that, I guess. From what I'm gathering, you don't need to follow it. Yeah, it still understands, but we're trying to be clean, I guess. So we should try to do that as much as possible. So that is our run. So run the code and observe the results. Which parts of the table are the clauses? So the clauses, so from select and from our clauses, right? What table are we applying the command to? Uncover the hint to view the answers. Okay. Yeah. What table are we applying the command to? The celebs is the table. That's what it's called, the celeb table. And then we're applying these clauses or commands to that celeb table. So select from the celeb table. That's basically all we have. So if we have the answers, select and from are the causes, and we're applying to the command to the celebs table. So easy peasy learning that part right there. Okay, so, Yeesh. Okay, anyways, so we're going to create a table, it looks like. So create statements allow us to create a new table in the database. You can use the create statement anytime you want to create a new table from scratch. The statement below creates a new table named celebs. So in our case, create table, celebs, and then ID integer, name text, age integer. So what they've just done in this particular situation here is that they created a table called celebs, and then they made the ID an integer, so a number. Name is a text, and then age is also a number. So that's all it really is. Yeah, and basically what I just said summarized all of that up right there. So what we're gonna do is we're just gonna, now that you have a good understanding of SQL syntax, we can create a new table. We cleared the database from the previous exercises. Confirm no celeb table exists by entering the following in the code editor. Select from celebs. So what they probably did was they just cleared everything off, so nothing to reference at this point. Right? 8 from celebs. Close that, and then we're gonna run that. Boop, there we go. So nothing in there. So now what we're gonna do now is we're gonna create a table right now. So we're gonna create a new table. Create a table, we're gonna call it celebs. And then we're gonna put a open bracket where ID is an integer. Name is going to be text. And then age is going to be also integer. Integer. Boom. Wait, what? Include name column in the table. Name column in the table. In the code editor type. Oh, we didn't do. Sorry. Boop, boop. And then we close. We didn't close. There we go. We didn't do the, so we need to be very specific. Commas are there to make it new columns, and then we need to close it off with the semicolon. All right, let's go. We can use the insert statement when you want to add new records. The statement below enters a record for Justin Bieber into the celebs table. So we're doing insert into celebs ID name range, and then the values. So there's a whole thing here that says what we need to do. So essentially, I think what we've done already is if we do select star from, and then we write celebs, close. This should be an empty table. Yeah, there's an empty table on the add one row to the table. Yeah, so what we're gonna do now is we're going to now do an insert into and then we're going to do celebs, and then we're going to add in ID, name, and age. So if we don't do those things, it won't happen essentially. So values is 1. We're going to call this Justin Bieber, and then we're gonna say 22. So if we do that, so essentially what we just done is it hasn't added this thing yet, I don't think, because we have only just inquired into the database, right? So now we're entering things into the database. So I mean, if I do this, insert into, oh my god, insert into celebs. So it's asking me to do more. So we'll continue on the lesson. ID, name, age, and we'll go into values again. Open that bracket. We're gonna go to beyond Noel's 33, and we're gonna close this argument off again. So we're gonna do semicolon, insert into celebs. And we'll do again ID, ID, name, age, and then we're going to put in a value of values. I'm sorry. We're going to do 3. Jeremy. Oh. Jeremy Lin. I think someone's a Raptors fan here. Whoever programmed this is definitely a Raptors fan. Into celebs. And we'll try that again. ID, name, age, values. We're gonna put that up again. Number 4. Taylor Swift. Oh, we didn't do the, I didn't do the thing. They're very specific. 26, and then we close this off with a semicolon. We close this out with a semicolon, and we're going to put ID as lowercase id. Boom. Run that. Add 3 more rows to the table. That's what I thought I did. Or maybe it doesn't like, it needs like, Oh, maybe I'm doing this wrong. Try that again. Add 3 more rows to the table. Huh? How is this not working? Look at the database schema. How many rows are in the celebs table now? What? Interesting. How am I not doing this right? Oh, wait, hold on. Maybe I may have made a mistake here. Maybe? Huh. Interesting. Is it something that I'm not writing incorrectly? Insert into celebs ID name age values 2 Beyonce nulls, comma 33. Insert into celebs. Actually, I wonder if I just, okay. I'm very curious now. What if I did was correct? There we go. Yeah, I thought this was going to be clean if I do it this way. Huh. Make sure you enter 3 new insert statements beneath the first insert statement. Oh, wait a minute. I did not close this off, did I? There we go. Oh man, that's very specific. I need to remember that part. That's oof. Yeah, I didn't close off the first. It breaks the whole thing down when you don't put in even the first or close off the first statement. That's nuts. That's crazy. Okay. Yeah, right on. Okay. So we put in some data right now. So now I guess what we can do is we can select the statements, then select the name from statements. Select statements are used to fetch data from a database. In the statement below, select returns all data in the name column of the celebs table. So select name from celebs. So if we do that, close that statement off. I just gotta remember every time I do the SQL, I gotta remove that. I know I'm pretty sure I've done the instructions because it's almost like exactly word for word for what they want me to do. Select is a clause that indicates that the statement is a query. You will use select every time you query data from the database. Name specifies the column to query data from. So from celebs specifies the name of the table to query data from. In this statement, data is queried from the celebs table. You can also query data from all columns in this table with select. Yeah, so they did this asterisk in this case is a special wildcard character that we have been using. It allows you to select every column in a table without having to name each one individually. Here the result set contains every column in the celebs table. So if we do the asterisk, then it'll be like a whole. And like if we try that, so if we do star, then it takes information from everything, not just the names. So let's see. Oops. Whoops. I'm messing up the code. So there you go. So in this case, as you can see, we are doing, when we put name only, You only get the names. That's it. No more, no less. Right? If we do ID, we're going to get all the ID numbers, and that's it. If we do age, we get all the ages, but it's not very helpful, right? Like names, name works, which kind of works because it's like there's a bit more of a label to everything. But like age doesn't really work. I mean, unless you're trying to use that age to do some kind of different analysis, but that's a whole different story, right? But if we use the asterisk, it basically searches for everything, which is the nice part. Statements select always return a new table called the result set. So this is the result set right here. So actually, curious, if I just did this, yeah. So there is actually, so yeah, we can actually look at the celebs table, and we can see what the heck's going on here, right? I think I remember how to do this. If I do it like that, I think. Oh, cool. It actually adds it together? No way. That's actually kind of neat. I like that. And age. I think if you do an and, if you run the and, oh, it's the plus. Never mind. Now, if you just do age. Uh-oh. I think I broke it. Oh. Uh-oh. Uh-oh. Oh no. I think I broke it. I broke SQL. Oh no. Oh no. What happened? Oh no, I broke it. Did I break SQL? No, I didn't. Lost connection to SQL. Lost connection to SQL. What did I do? Did I break it? Did I actually break it? No. There's no way. There's no way. There's no friggin' way I broke SQL. It's loading. What did I do? So if I go back, if I run this, there we go. I don't think I did very well. I think I broke it. So if I have to run a secondary line, select ID from celebs. Close that. It runs two different things, but you can't go side by side. I thought you could. I'm pretty sure you can. I'm just not knowing the syntax well enough just yet. But I'm pretty sure if I like wrote something, I can probably find out what it is, I guess, maybe. I don't know. Meh, we'll see. It's all good. So yeah, database management, all right. Oh, 1 second here. 1 second here. Huh. Okay. Anyways, sorry. Let's push on a little bit further. We're almost done here. Looks like, yeah. Alter, update, delete, constraints, review. Yeah, we're almost done for this part. The alter table statement adds a new column to the table. You can use this command when you want to add columns to a table. The statement below adds a new column Twitter_handle to the celebs table. So we're saying alter table celebs. What are we trying to do? We're trying to add a column to the Twitter with a Twitter handle, and the Twitter handle will have the text function on there. So that's all it really is, which is amazing. Cool. All right, let's go. So I'm assuming what we're gonna do is we're going to now do alter table celebs. Okay, we're gonna add column LUMN, yep, Twitter underscore handle, and then it's going to be a text item. I'm going to close the statement there. If we run that, now we should have a Twitter handle at the bottom right there. There you go. There we are. And then we can do a select from, which we kind of did. They kind of did for us. Select star from, and then celebs. And we're gonna close that up. And then boom. So now we can actually do a select from. You can actually see that there's all these things, and then we don't have the Twitter handle from them just yet, but we do have the database scheme, right? So what we have is ID, name, age, Twitter handle, boom, 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 and boom. There you go. So next, what we're gonna do is we're gonna add in update. We're gonna add an update to the SQL. So we're gonna update the celebs. Was set Twitter handle underscore handle, and then it's going to say equals, and then we'll do at Taylor Swift 13, and then we're going to put it where. So where are we going to put ID equals 4. Close statement. So now what's going to happen, and then we're going to select star from celebs. We want word for word here. There you go. So now, because of what we just did, the update, we said the update, what do you want to update? The set is a Twitter handle. So what are we going to try? We're going to set that Twitter handle of Taylor Swift, Taylor's at Taylor Swift 13. Where is it going to go? In ID number 4. I'm pretty sure if you put in name or name equals 4, or like name equals Justin Bieber. No, that won't do it. That's too bad. So it has to be an ID. So we have to assign what the ID looks like. Yeah. You can't do name, I guess. That's too bad. So you have to go with an ID of some sort, which is, I mean, it kind of works, I guess. I mean, it will work because everything's always assigned to an ID of some sort, right? So you can't just have like, I guess you can have triplicate of names, right? You can have people that are named, you know, John Smith like 17 times, right? And which ID are you really referring to? So we got to do is catch all for those Jonathan Smiths or John Smiths, and then like kind of figure it out from there. You know what I mean? So I completely understand. I understand this situation here. Give me a second here. Oh, puppy dogs, cute. Delete. Oh, okay. So we got to, if you want to remove something this time around, the delete from statement that deletes one or more rows from the table. You can use the statement when you want to delete existing records. The statement below deletes all records in the celebs table with no Twitter handle. Interesting. Okay, so we're gonna do delete from celebs. Okay, where Twitter handle is null. So, and we close that statement off. So what happened here is that we're going to delete from the table or from our database celebs Where is it deleting from? It's deleting from Twitter handle, and is the operative one null. So there's nothing there. It won't show, or it'll kind of delete it there. So what we're gonna do now is we're gonna do a select star from celebs, and we're gonna close that statement. So we're gonna run that separate statement. So anyone who's not on our list that has a Twitter handle just won't be there, right? So, I mean, we can probably also do set celebs. How did that work again? I completely forgot. 1 second here. Underscore Twitter handle equals, okay, yeah, so if we do set Twitter underscore handle equals, and then we'll do at Mikey Maddox, we can add in a, oh wait, hold on. Oh my god, I keep on forgetting. I don't remember that part. Oh no! There's a whole thing I gotta remember. Hold on, wait. I can do this. Update. It's update set where. Okay, update set where. Update, so we're gonna do an update. Ugh, this sucks, okay. Update. Celebs. Set. Twitter underscore handle equals at Mikey Maddox. And then we're gonna go where ID equals 2. I'm gonna close that statement, and then if we do that, oh no, oh. So we can't do that. So I think if I do it that way, there you go, yeah. So ordering is also really important. I forgot about that. If we delete from celebs right away and then we add in the update, it doesn't matter. It doesn't make any sense because the computer doesn't read things in alternate directions. They have to update it. Or what I could have done was I could have stuck with delete from celebs where Twitter handle equals null. Do the update and then do another deletion again. No, that's not going to work. No, you have to input the new thing in first. Yeah, no. Ordering has to happen in that way, or else like you can't do it. Yeah. So Beyonce Knowles, Twitter handle is Mikey Maddox. There you go. It's truth fact right there. Right there. Boom. That's how you find Beyonce Knowles. You go to Mikey Maddox. That's how you find Beyonce. Look out, Beyonce! Here I come. Getting your Beyonce clout, getting that Queen Bee clout. What up? Constraints. I think we're in like this final part right here. Yeah, constraints. This part's going to be a little bit of a maddening situation here, but that's okay. Constraints. Constraints add information about how a column can be used. Are invoked after specifying the data type for a column. They can be used to tell the database to reject inserted data that does not adhere to the certain restrictions. The statement below sets constraints on the celebs table. So what are the constraints? In our case, we're going to create a table, ID, integer, primary key. Name text is unique. Date of birth text not null. Date of death, text default not applicable. Wow, okay, so we got some interesting parts right here. So the primary key columns can be used to uniquely identify the row. So, okay, interesting. Attempts to insert a row with a identical value to a row already in the table will result with a constraint violation, which will not allow you to insert the new row. Okay, interesting. Unique columns have a different value to every row. This is similar to primary key, except a table can have many unique columns, very many different unique columns. Not null columns must have a value. Attempts to insert a row without a value for a not null column will result in a constraint violation, and the new row will not be inserted. So, okay. So let's do the fourth one. Default columns take an additional argument that will be the assumed value of the inserted row if the new row does not specify a value for that column. Okay, what does that all mean? Okay, I'm gonna try and figure that out in my head. So primary key columns can be used to identify the row. Primary key columns can be used to uniquely identify the row. Okay. Attempts to insert a row with an identical value to a row already in the table will result in a constraint violation. Okay, so you can't have more than one ID of the same ID type. So the primary key can only be like 1, 2, 3, 4, 5, 6, 7. You can't have one table, a table with double ones or double twos. You can have 11 and you can have 22, obviously, but you just can't have 1, and 1, or 2 twos, or 3 ones. Yeah. Unique columns have a different value for every row. This is similar to primary key, except the table can have many different unique columns. So you can have different columns, which is nice, but you can have different. You can have the same information, sort of, I think, in the same row, in a way. So these two kind of work with each other in a way. You can have, right? You can have unique columns, and these do columns, these do rows. It looks like. And then not null must mean that you have to have something in the column. Yeah. And then default columns default columns take an additional argument that will be the assumed value of an inserted row if the new row does not specify a value for that column. Interesting. Okay. I'm not too sure what that really all means still. I'm still trying to wrap my head around that. That's okay. We're all kind of learning here, which is the nice part. So we're going to open up ID integer called primary key. And then we're going to do recipient text not null. And then finally, we're going to do award underscore name text default is Grammy. Not Frammy, Grammy. And then we close this off with a closed statement right there. Make sure they all have the constraints set. Award underscore name, text default, Grammy, not null, and then primary key. I really make sure the columns have the appropriate constraints set. Did I not do it right? No. Oh man. Okay. I'm gonna try and figure this out. Okay. Recipient text. I feel like I need to do everything all cap letters. Table awards. So the table is called awards. That's fine. ID integer. Integer is primary key. Recipient text not null. Follow the conventions, Mikey. Follow the conventions. Not null. Award name text. Default is Grammy. There we go. So it looks like we have now two tables. One table is the celebs ID, and the next table is the awards ID. ID is integer, recipient equals text, award name equals text. Default is Grammy. So if we do select star from awards, close that statement. We're going to take that run there. Oh, there's nothing. Well, we don't have any data. That's right. We don't have any data yet, so we can't select really anything specifically on that. That's okay though, because there's no rows. Yeah, but that's okay. We'll have to figure out more things next time around. Tomorrow probably. Yeah. So, but we learned a few things. We created a table, insert into, select, alter table, update, and delete from. So we can. So essentially, we learned a couple of interesting things here. When we create a table, we obviously create a whole new table. If we insert into, we add a new row into the table. Select queries the data from the table, so we can actually just ask it questions, right? Alter table changes the existing table with an update of, update the row or delete or whatever it may be. So we can do an alter table to make it a new column, so make it a larger column. Update, we can update rows if we want to. So yeah, we can kind of go back and forth between all these all day if we really wanted to. Yeah, so I might open up the cheat sheet for next time just because it makes sense. But that's okay. You know what? This pro is starting to look better and better every time I look at it. The repetition of what's it called? The repetition of marketing is kind of working right now, which is kind of weird. I don't like it, but it is what it is. It is what it is. Okay, well, today I came in late, so I definitely want to make sure I jump into the next hour right now with stuff at Twitch. So what I'm gonna do is we're gonna just stop it here for now. SQL is going to be our new course part. So we're going to learn how to do the queries, right? So still part of manipulation, but we're still getting into the queries part, right? So we're going to learn a bunch of that tomorrow, and then aggregate functions and multiple tables, and then hopefully that's a week right there for us, right, as well. Cool. All right. So. Thank you so much, everybody. We shall see you tomorrow, hopefully.